In this video, we are going to take a look at understanding and representing exponents. So the first thing that we're going to do is we're going to take a look at what makes up the exponents. So the base is the number being multiplied by itself. So in this case, the 9 is the base because it is going to be the number that is multiplied by itself. And then in this case, the 6 is the base because it is the number that is going to be multiplied by itself. And then the exponent determines the number of times that that base is multiplied by itself. So in this case, we have an exponent of 5. So that means this 3 is going to be multiplied by itself 5 times. So it will be 3 times 3 times 3 times 3 times 3. It is not 3 times 5. That is not what that means. It means this 3 is multiplied by itself 5 times. And in this case, we have an exponent of 7. And so I'm going to multiply this base of 2 times itself 7 times. So we would have 2 times 2 times 2 times 2 times 2 times 2 times 2. Again, it is not, oops, it is not 2 times 7. That is not what that means. It means 2 multiplied by itself 7 times. So in this case, we have an exponent of 4 because it is our little number that is up to the right and the top. And then we have a base of 3. In this case, we have an exponent of 3, and we have a base of 7. And here we have an exponent of 2 and a base of 9. Here we have an exponent of 9 and a base of 8. Here we have an exponent of 0 and a base of 12. So now we're going to look at how to write these in different forms. So writing them as an exponent form is written as a small number to the right and above the base number. So again, the base number is the number that I am multiplying by itself, which is in this case 6. And I am multiplying by 6 itself 1, 2, 3 times. So my exponent is 3. In this case, I'm multiplying the fraction 2/3 times itself, and I'm multiplying it once, twice, 3 times, 4 times. So I would write it as 2/3. And then I'm going to put parentheses around it and then put my exponent of 4. The reason I need to put parentheses around it is because that's telling me that I am taking the whole fraction of 2/3 and raising it to the 4th power. Or I could write it as 2 to the 4th over 3 to the 4th. But if I just write 2 to the 4th over 3, that means I'm just taking the 2 to the 4th power, and I want to take the entire fraction of 2/3 to the 4th power. So I'm either going to write it this way or I'm going to write it this way. This is probably the most common way that you're going to see it. Now I'm going to talk about expanded form. So expanded form is when I write the expression to show the value of each individual number. So here I have my base of 6, my exponent of 3. So again, I'm taking 6 multiplied by 6 multiplied by 6. I have my base number of 6, and I'm multiplying it by itself 3 times. So here I have 2/3 to the 4th power, which means I have 2/3 multiplied by 2/3 multiplied by 2/3 multiplied by 2/3. Again, 2/3 is my base number, and I am multiplying it by itself 1, 2, 3, 4 times. Standard form. So standard form is basically evaluating or solving the expression. So again, my base is 6 and my exponent is 3. So that means I'm taking 6 multiplied by 6 multiplied by 6. And this time I'm actually going to say that 6 times 6 times 6 is equal to 216. So I'm taking this and coming up with an answer. And here I have 2/3 to the fourth power. So again, I'm taking 2/3 multiplied by 2/3 multiplied by 2/3 multiplied by 2/3. And so in doing that, I would take 2 times 2 times 2 times 2 and get 16. And then I would take 3 times 3 times 3 times 3 and get 81. So I am taking this expression right here and simplifying it or solving it to its simpler form. So now let's fill out this table. So some of it's giving us our exponent form, some of it's expanded form, and some of it's standard form. And we need to fill out the rest of it. So here I have a base of 2 because that's the number I'm multiplying by itself. And I have 1, 2, 3, 4, 5, 6, 7. So my exponent form would be 2 to the 7th. My standard form would be taking 2 times 2 times 2 times 2 times 2 times 2 times 2, which gets me 128. Here I have a base of 7, and it's to the third power. So that means I have 7 times 7 times 7, because I have my base of 7, and I'm multiplying it 1, 2, 3 times itself. And that gives me an amount of 343. 9 to the first power, that just means I have 1 9. So standard form would be 9. Now here I have a standard form of 25. So I need to think about the factors of 25. Well, I have 1 times 25, and I have 5 times 5 is 25. Well, when I'm dealing with exponents, I'm taking the same number times itself, which in this case would be right here, 5 times 5. So that would be my expanded form. And then I know that I have two fives, so it would be 5 to the second power. Here I have 2 and 3/10 to the third power, so that would make it 2 and 3/10 multiplied by 2 and 3/10 multiplied by 2 and 3/10. And when I multiply that out, I get 12 decimal 167. Here I have 3/4 times 3/4 times 3/4. So that is 3/4 to the third power. And I know that 3 times 3 times 3 is 27. I know that 4 times 4 times 4 is 64. So my standard form would be 27 over 64. Here I have a decimal of 1.5 times 1.5 times 1.5 times 1.5, which gives me 1.5 to the fourth power. And when I solve that or put it in standard form, that gives me 5 decimal 0.625. So again, here I have 81 in my standard form. So if I think about some factors of 81, well, I know have 1 times 81. I also know that I have 9 times 9. So that would make my expanded form 9 times 9. And that would make my exponent form of 9 squared. Here I have 4 to the 0th power. And any number to the 0th power is always equal to 1. No matter what number it is, whether it's 4 to the 0th power, 100 to the 0th power, 5 6 to the 0th power, it is always equal to 1.